Welcome, all stargazers, to a cosmic journey into the heart of our own galaxy, the Milky Way. For centuries, we have gazed up at the night sky, charting the luminous tapestry of stars, gas, clouds, and dust that define our galactic home. But what if I told you that there is something lurking within the dense core of the Milky Way, alongside the supermassive black hole known as Sagittarius A star? There could be another far stranger population of the celestial objects made of something we can't directly see, touch, or easily understand, and that is known as the dark matter. And therefore, in this video, we will be diving deep into the fascinating and still largely theoretical concept of the dark matter stars, sometimes called the dark dwarfs, that might be residing right at our galaxy's center. It's a mind bending idea that could revolutionize our understanding of dark matter itself and the very architecture of the galaxies. So, buckle up, friends, because we are about to explore the shadowy side of the cosmos. Before we can even begin to imagine the stars made of dark matter, we need to tackle the fundamental question: what exactly is dark matter? For decades, astronomers have observed compelling evidence that the visible matter we see, that are stars, planets, and galaxies, only account for a small fraction of the total mass and energy content of the universe. The rest is staggering 85% or so is something invisible, something that doesn't interact with light or any other electromagnetic radiation in any significant way, and therefore we call it dark matter. We know the dark matter is there because of its gravitational influence. We see its effects on the rotational speed of the galaxies, the bending of light around galaxy clusters, and the large scale structure of the cosmos. Without the gravitational pull of the dark matter, galaxies would fly apart and the universe as we know it wouldn't even exist. But despite its overwhelming abundance and crucial role, the precise nature of dark matter remains one of the biggest mysteries in modern physics. Scientists are exploring various possibilities, from exotic particles like weakly interacting massive particles or WIMPs to hypothetical ultra light bosons and even the modifications of the law of gravity. The search for dark matter is one of the most active and exciting field in scientific research. So how could this elusive substance form something as seemingly concrete as a star? The idea stemmed from the understanding that if the dark matter particle can interact with each other, even very weakly, and lose energy through these interactions, they could potentially clump together under their own gravity. In the early universe, when density of the matter was much higher, it is theorized that these dark matter clumps could have grown significantly. If enough dark matter amassed in one place, the gravitational pressure at that core could become immense. Now, this is where things get really interesting and speculative, of course. Unlike ordinary stars, which ignite through nuclear fusion of hydrogen into helium, dark matter wouldn't produce energy through this electromagnetic interaction. Instead, their energy source would likely be an annihilation of the dark matter particle within its core. If certain type of dark matter particles are their own having their own antiparticles, they could collide and annihilate, releasing energy in this process. The properties of these dark matter stars would be vastly different from those of the ordinary stars. They would be incredibly dense, composed primarily of dark matter, and potentially much cooler and fainter if they emit any detectable radiation at all. So, why focus on the center of the Milky Way as a potential breeding ground for these dark matter stars? Well, The galactical core is the most dense region of our galaxy, and not just in terms of visible matter, but also in expected concentration of dark matter. According to many models of the galactic formation, dark matter halos are densest at the center. This high density environment would significantly increase the chance of dark matter particles interacting and collapsing to form these exotic objects. Furthermore, the immense gravitational pull of the central supermassive black hole could also play a role in trapping and concentrating the dark matter in this region. Imagine a scenario where our billions of years and trillions of years, eons basically, countless dark matter particles have been drawn into galactic center, gradually accumulating into these unseen stellar bodies. They wouldn't shine like the familiar star we see, but their gravitational influence could still be significant and potentially affecting the orbits of nearby stars and gas clouds in a very subtle way. The biggest challenge, of course, is detecting something like this, and that by definition doesn't interact with light. How could we ever hope to find these elusive dark matter stars? One potential avenue is through their gravitational effect. If a dark matter star is massive enough, it could exert a detectable gravitational pull on nearby visible stars, causing light deviations in their orbit that astronomers might be able to observe with highly precision based instruments and telescopes. Another possibility lies in the product of the dark matter annihilation. While dark matter itself doesn't emit light, some annihilation scenario predict that the release of high energy particles like gamma ray, neutrinos, or even antimatter particles could happen because of this annihilation. Telescope designed to detect these type of radiation might be able to pick up the unusual signals emanating from the galactic core. That could be a signature of the dark matter annihilation within these hypothetical stars. However, the galactic core is already very busy and energetic place with numerous sources of high energy radiation, including the supermassive black hole itself. Disentangling a potential dark matter signal from this background noise would be an incredibly difficult task, requiring extremely sensitive instruments and sophisticated data analysis technique. If the dark matter star do not exist at this location, or do even exist at the heart of our galaxy, their discovery would have profound implications for our understanding of the universe. Firstly, it would provide crucial clues about the fundamental nature of the dark matter itself. The property of these stars, such as their mass, size, and the potential energy output, could help scientists narrow down the possibility for the type of particle that makes up the dark matter and the strength of its interactions. Secondly, the presence of the significant population of the dark matter stars in the galactic core could influence our models of galactic evolution. Their gravitational interaction could affect the distribution of the ordinary stars and gas, and they might even play a role in the dynamics of the central massive black hole. Furthermore, the discovery of dark matter star in our own galaxy would suggest that there could be a common phenomena in other galaxies as well. This could have significant implications for our understanding of the formation and evolution of galaxies across the cosmos. The idea of dark matter star lurking at the center of our Milky Way galaxy is a testament to the ongoing quest to unravel the mystery of the universe. While still firmly in the realm of theoretical astrophysics, the possibility that these exotic objects exist highlights the vast amount we still don't know about the domain form of matter in the cosmos. The search for dark matter continues on multiple fronts, from direct detection experiments deep underground to collider experiments smashing particles together at nearly light speed, and of course, through astronomical observations of our galaxy and beyond. Whether or not we ultimately find evidence of dark matter stars in our Milky Way's core, the very act of exploring these possibilities pushes the boundary of our scientific understanding and inspire us to imagine the universe in new and exciting ways. So, thank you, friends, for joining me on this journey into the shadowy heart of our galaxy. Keep looking up, keep wondering about the amazing universe we live in. See you in the next one.